Hello, awesome student. This is the review for reassessment day number 1. Remember, the mandatory standards are 9D and 9E, which is on the first page here. And the optional standards are 6B and 9A. Let's begin. So for standard 9D, it's system of equations including quadratic functions. The idea is to determine how many times it's possible for two different types of functions, or perhaps the same type of function. How many times do they cross? And where they cross is considered a solution. It's a coordinate. So this one has one solution where a line and a parabola cross only once. What are the solutions? The solution is the coordinate where they cross. So -2, 5 is where they cross. For letter B, it looks like this circle and this parabola only cross once as well, and it crosses at 2, -4. For number 2, it's asking us to sketch a graph that fits each description. So we have to draw a line and a circle that intersect 3 times. Well, if we draw a circle and a line may cross once, a circle and a line may cross twice, but it is impossible to intersect 3 times. So I can say not possible. For letter B, a parabola and another parabola that intersect only once. There are multiple options for this. The first option is, say we have our typical parabola, x squared, but then we have another parabola that is stretched and they only cross once. That's one possibility. Another possibility is you could have a parabola opening up and another parabola opening down. They would cross only once. And those are pretty much the only options. There is one more actually. If you draw a parabola that looks like this and a parabola that also is opening down but they only cross once, those are all possible options for parabolas crossing or intersecting only once. Okay, now we're going to move on to number 3. These are systems of equations. As you can see, we have lines and parabolas. You can also get 2 parabolas. You can expect to see that on a test or an assessment for this type of standard. You can have a parabola and a line, as we have for pretty much all 3 of these examples. And it's possible that they cross twice. 2 solutions. It's possible that they cross once. And it's possible that they don't even cross at all, which would be no solution. So let's start off with number 3. Use an algebraic way or method to determine the points of intersection, if any exist, for the system. And for letter A, we got to graph the system to verify our conclusion. So for number 3A, we are going to recognize that this is a line and this is a parabola. That's going to be quadratic. So we're going to have to put them into y equals form. Just like these problems right here, letter B shows y equals, letter C shows y equals. For letter A, we'd also want them to be y equals. So how do I get x plus y equals 5 into y equals form? That's right, we got to subtract x. So that gives us a new equation. Y equals 5 minus x, or you can say negative x plus 5. 5 minus x, negative x plus 5, it's the same thing. Now for the second one, we also want this to be y equals, so I'm going to have to subtract 1. That gives us a second equation of y equals 3x squared plus 2x minus 1. At this point, I could decide to graph it on the coordinate plane, but I'm going to solve it algebraically, where I set these two equations equal to each other, and I will find their point of intersection. So let's set this equation equal to that one. (3x squared plus 2x minus 1 equals negative x plus 5. All right, my next goal is to set it equal to 0 so I can use a method such as factoring, quadratic formula, or even completing the square. Or in this case, we can check our work by graphing. So one of these methods we're going to be able to use if we set it equal to 0. So the way that I set this equal to 0 is I'm going to be adding x to both sides and subtracting 5 to both sides. That gives me 3x squared plus 3x minus 6. At this point, I could decide how would I want to solve this. Would I want to solve this using factoring? Would I want to solve this using another method? You could use the quadratic formula if you want to. I'm personally going to share a method that I like. I'm noticing all these numbers, the number 3 goes into each of these numbers. So I'm going to divide by 3. My method. Again, it's just my choice. You can decide how you'd like to solve it as well. That gives us x squared plus x minus 2 equals 0. Since we do 0 divided by 3, it's still equal to 0. Now, if I factor this, I will get my two solutions for x. So I'm going to find out what multiplies to negative 2 and adds to 1. The two numbers that multiply to negative 2 and add to 1 are 2 and negative 1. So we have x and x. We have plus 2 and minus 1. Using the zero product property, we're going to get our two solutions for x. We're going to get negative 2 and also x equals positive 1 when we switch the signs. So those are my x solutions. I know it's going to be negative 2 comma something and also 1 comma something. So now what I need to do is I need to input these two values into one of these two equations. Now, which equation looks easier to you? The top equation or the bottom, right? So I'm going to choose to input it into the first equation. First off, inputting negative 2. We got negative 2 plus 5. Negative negative is positive. 2 plus 5 is 7. So when x equals negative 2, we get 7. Now I'm going to do the same for the second value of x. I'm going to input 1 into that equation as well. I will get y equals negative x plus 5, y equals negative 1 plus 5. Negative 1 plus 5 is 4. So when I have 1 in as an input, the output is 4. So again, all I did was substitute those two values in for the x, and then it gives me an output of y. For the first answer, it was 7, and for the second solution, it was positive 4. So this question asks us to verify our answers based on the graph. So our first equation is negative x plus 5. So that's going to be a y-intercept of 5 and a slope of negative 1. Something like that. And our equation is going to be a 3x squared plus 2x minus 1. I know those are x-intercepts of -2 and +1. The y-intercept is -1. I actually made a mistake. This is not the same equation as this one. But if we do graph these, creating either a t-chart for this equation right here, we will get a y-intercept of -1. And since it's stretched by a factor of 3, they will end up crossing at -2, 7. And also 1, 4. So the parabola looks something like this. Okay, the next problem is going to be problem 3b. For this one, I'm going to set them equal to each other. We have x squared minus 2x minus 3 equals -5. I will add 5 so that it's equal to 0. That gives me x squared minus 2x plus 2 equals 0. If you tried to factor this, this was not possible to factor. So instead we'd have to use the quadratic formula, where a is 1, b is -2, and c is +2. So we get negative b plus or minus the square root of b squared minus 4ac all over 2a, giving us -2 plus or minus the square root of -2 squared minus 4 times 1 times 2 all over 2a, with a which is 1. Why is a 1, by the way? The a value is the number 1 that's in front of x squared. So solving for x, we're going to get 2 plus or minus the square root of 4 minus 8 all over 2. What happens if you do 4 minus 8? That will be a negative number. So this one we can say there's going to be no solution. As a matter of fact, you could graph these using your graphing calculator and see that these two equations would actually not cross. So let me try again. I think the camera was off screen. My apologies for that. It was, when I did 4 minus 8, that was -4. That would be imaginary, so there's no solution. But I'm going to check with my graph calculator. X squared minus 2x minus 3, and y is -5. If I graph those right there, it'll be a parabola, and it will be a horizontal line. That parabola and the horizontal line do not cross, so therefore it's no solution. Okay, letter C. For letter C, I'm going to set -x squared plus 2x plus 7 equal to -2x plus 2. My next step is to set it equal to 0. So I will subtract 2, and I will add 2x just by doing inverse operations. That leaves me with -x squared plus 4x plus 5 equals 0. At this point, I would like to divide by -1 to get rid of the negative sign. That gives me x squared minus 4x minus 5 equals 0. Applying the factoring, I will see what multiplies to -5 and adds to -4. The two numbers that multiply to -5 and add to -4 are going to be -5 and 1. So -5 plus 1. Most of the equations that you're getting on the test are going to be similar to this, where it's factorable and you're going to get pretty much 2 answers. Sometimes it's possible to get 1 answer as well, but in this case we're going to have 2 answers. So we get, our first solution is x equals 5. Our second solution is x equals -1 just by switching the signs. So if I now plug in or substitute that number into the second equation, or the easiest equation, excuse me, I will get my two solutions. So if I plug in 5, I will get -8. So 5 comma -8 is our first solution. And if I plug in -1, I will get 4. So -1 comma 4 is our second solution. Okay, let's move on to standard 9e. Standard 9e is finding the inverse of linear and quadratic functions. So my first step is to write y equals 21 minus 6x. Second step is to switch x and y. And my third step is to solve for y to get y by itself. So I'm going to subtract 21. That leaves me with x minus 21 equals -6y. Now my next step to get y by itself is to divide by -6. So after I divide by -6, I'll get my answer of y equals x minus 21 over -6. Now just leave your answer like that. That answer shows the inverse operations that were done. And now our final step, step 4, is to say f inverse of x. So our final answer is f inverse of x equals this. X minus 21 over -6. That's our answer. Letter B. Letter B, I'm going to do the same steps. Y equals x minus 2 squared plus 11. Switch x and y. And now I want to do the inverse operations in the correct order, so I'm going to first move what's furthest away from y. I'm going to subtract 11. Now to get y by itself, I cannot add 2. I will need to square root both sides. That gives me the plus or minus square root of x minus 11 equals y minus 2. Those two cancel out. And it's only plus or minus if you're taking the square root. They're two solutions. So now my final step would be to add 2. So I can write that finally as 2 plus or minus the square root of x minus 11. Just putting the 2 in front. Okay, next up is problem letter C. I'm going to do the same steps. Y equals -3x minus 9 over 4. Switching x and y, I'll get -3y minus 9 over 4. Completing the inverse operations, I will multiply by 4 to get rid of the 4. I will add 9 to get rid of the -9. And I will divide by -3 to get rid of the -3. So my final answer is k inverse of x equals 4x plus 9 over -3. Okay, letter D. Letter D is a very strange one, but I'm going to go ahead and try to solve this one. Y equals 3 over 2 minus 7 root x. Switching x and y, I'll get 3 over 2 minus 7 root y. I will try to get y by itself, so I'm going to go ahead and get rid of this 3 over 2 first. So I will subtract 3 over 2. leaving us with x minus 3 over 2 equals negative 7 root y. I want to get rid of the negative 7, so I'm going to not add 7 because this is multiplication. So the opposite of multiplication is division. I'm going to divide by negative 7. Now that leaves me with x minus 3 halves over negative 7, which does look very weird, I will admit, equals the square root of y. And to get rid of the square root, we'll do the opposite of square root, which is square. So I'll square both sides. Now my final answer is whatever is shown here. So I'll say t inverse of x equals x minus 3 halves all over negative 7. All of that is squared. And that's my final answer for 9E. Okay, let's flip our page to standard 6B. Okay, standard 6B and 9A are the optional standards. So we're going to go ahead and do our best to complete these. So for number 1, we want to combine the 5 and 3, it gives us 15. And we want to combine the 14 and the 7 under one square root symbol. What is 14 times 7?
It's 98.
So we get 15 root 98. Now what we want to do is we want to simplify 98. What is a perfect square that goes into 98? We're talking about 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, or even 10 squared. Now, which of these numbers is the biggest number that goes into 98? And that number is going to be 49. So I'm going to write 15. And 98 becomes 49 times 2. That leaves us with 15. Now the square root of 49 is 7. And the square root of 2 is just the square root of 2. 15 times 7?
It's 105.
So our final answer is 105 root 2. Okay, for our next problem, number 2, we are going to rationalize the denominator. So we're going to multiply by root 32 over root 32. That's because we don't want any square roots in the denominator, so we have to rationalize it. If this was 5 root 10, we'd do root 10 over root 10. If it was 5 root 82, we'd do root 82 over root 82. But since it says 5 root 32, we're going to rationalize it by this giant one. That gives us 4 root 32 over 5 times 32. Root 32 times root 32 is 32, leaving us with 4 root 32 over 32 times 5.
It's 160.
160. So now I'm going to try to simplify this even further. What is 160 divided by 4?
The answer is 40.
So I know this simplifies to 1 over 40. So that gives me root 32 over 40, since those simplify to be 1 over 40. Now, root 32 can be simplified. Root 32, which of these numbers goes into 32? The biggest one that goes in is 16. So we can write this as root 16 times 2 over 40. That gives us the square root of 16 is 4. 4 root 2 over 40 becomes root 2 over 10. Because 4 divided by 40 is 1/10. So that's a lot of steps to get to our answer, but that would be the correct answer. Okay, next up is number 3. This is just an addition problem. We're going to go ahead and do -3 plus -5. It's -8. And then -4i plus -i is -5i. That would be the correct answer. Now, it would be very different if this was a negative sign here, right? Because if it was negative, you'd have to distribute. So be prepared for that one. Okay, this next one is going to be dealing with imaginary numbers as well. Remember, for imaginary numbers, there's only 2 rules. I is the square root of -1, and I squared is -1. So for this one, we're going to use an area model to multiply 2 plus 7i and 1 minus 9i. Now, carefully multiplying these values together, I'm going to get 2 times 1 is 2. 1 times 7i is 7i. -9i times 2 is -18i. And -9i times 7i. -9 times -7.
That would be 63.
Or, actually made a mistake. -9 times 7.
It's -63.
So I'm going to do this one on the side. -9i times 7i. We get 63i squared. I times I is I squared. But what is I squared? I squared is -1. So we're going to get 63 times -1, which is -63. So this value right there would be -63. So now combining the like terms, I'm going to get 2 minus 63 is, well, my brain's a little slow. Let me just go ahead and use a calculator. 2 minus 63.
The answer is -61.
And then combining the -18i and 7i, -18 plus 7.
It's -11.
We get -11i. So that is the answer for number 4. Okay, moving on, we're going to go ahead and tackle another imaginary number problem. For this one, I'm going to write it as root 8, because when I have 2 negative numbers like this, I don't want to make any mistakes. So I'm going to write this as root 8i and root 44i. Okay, combining 8 and 44. 8 times 44.
The answer is 352.
We get root 352, and combining I and I, we're going to get I squared. Now what is I squared? I squared is -1. So that's going to give us root 352, but it's going to be negative. So for 352, I'm going to decide which of these perfect squares might go in. I don't imagine anything bigger than 100 will go in, but let's try dividing by some of these. 352 divided by 81.
It's approximately 4.3456.
That won't work. 352 divided by 64.
It's 5.5.
That doesn't go in. 352 divided by 49.
It's approximately 7.1836.
That doesn't work. 352 divided by 36.
It's approximately 9.7777.
Interesting, doesn't work. 352 divided by 25. Yeah.
That would be 14.08.
I don't think that would go in. 352 divided by 16.
The answer is 22.
So we're going to get negative. 16 does go in. That's great. Just like last time, 16 will go in again. So it's going to be 16 times 22. Well, what is the square root of 16? The square root of 16 is 4. And since there's a negative out there, we're going to add -4. And then 22, I know, cannot be simplified any further. So that's going to be the answer for number 5. For number 6, I'm going to rewrite this as a radical. So for radicals, you need to write the 2 here, the 3 here. Now, I'm going to check. You could do this right here. You could do 343 squared. That's just too big of a number though. So I want to check if we could do the cube root of 343. I'm pretty sure there is a number that goes into 343. So I'm going to go to math. Cube root is option 4. I'm going to type in 343, and it'll get me 7. So the cube root of 343 is 7, and 7 squared is 49. So the answer for number 6 is 49. Next up is number 7. Number 7, remember a square root, there is a square there, so this could be rewritten as x to the 8/2 power. X to the 8/2 power is the same as x to the 4th, since 8 divided by 2 is 4. For number 8, I'm going to go ahead and simplify this. Now there are multiple ways to do this problem, so I am going to show it in 2 different ways. The first thing I'm going to do is I'm going to simplify 24 divided by 16. Since I know that 8 goes into both those numbers, I'm going to rewrite this as 3 over 2. Now, I'm going to separate each of these x's, the y's, and the z's just so I don't make any mistakes. So it's a great way to organize it as well. If I have any negative exponents, I'm going to move them to the denominator. And if I have any negative exponents in the denominator, I'm going to move them to the top, or the numerator. So since this is negative, I'm going to move that to the denominator. So we have x to the 7th down here. We also have x squared, since negative needs to become positive. For this one, negative needs to become positive by switching it to the top. Negative also needs to become positive by switching it to the denominator. So we have y cubed. Finally, we have negative in the denominator, so we have to move it to the top. We're going to get z cubed, z to the 4th. So now combining everything together, now that we have everything positive, we're going to get 3 over 2 y to the 5th, z to the 4th times z cubed is going to be z to the 7th. And in the denominators, we're going to have x to the 9th and y to the 3rd power. Now I forgot to combine these two right here. If we have y to the 5th and y squared, that's going to be if I have y to the 5th and y cubed, that's going to cancel out and give us y squared. So we're going to be left with 3 over 2 y squared, z to the 7th, and in the denominator is x to the 9th. Now, if you found that way to be pretty annoying, I can see that you can see it's very easy to make mistakes with that. So finally, I will show you one other method. So 3/2, we know that has to occur. But what can I do about this exponents? If I have x to the negative 2 and x to the 7th, and it's a fraction, all I got to do is just subtract them. What's negative 2 minus 7? Negative 2 minus 7. It's going to be negative 9. And if it's negative 9, that means it needs to be in the denominator as positive 9. Now that's the x's. Now focus on the y's. We have negative 3 minus negative 5. Now what's negative 3 minus negative 5? Negative 3 plus 5 is squared. So we get y squared. Now finally the z's. Let's subtract the z. We get z to the 3rd power minus z to the negative 4th power. 3 minus negative 4 is positive 7. So we know that it has to be z to the 7th power in the numerator. So that is another way to get the same answer as shown here, just by using the subtraction rule. Okay, finally we're going to go ahead and go over standard 9a, which is transforming parabolas and quadratics. So for this standard, we do need to have, it's either going to be an absolute value function, or it's going to be a parabola. Notice they're not very different, so it's all based on these two formulas. So for the first one, it is an absolute value function. So remember, since it's minus h, we need to switch the sign, and this is going to be hk is the vertex. Just like here, hk is the vertex. So since you want to treat this sort of like parentheses, so if you have negative h, you're going to have to switch the sign for the vertex. So it's going to be, it says a vertex at negative 10, switch the sign, comma 3, keep the sign the same. It opens downwards, so it needs to be negative, and it has a stretch factor of 2/3. I will just say negative 2/3. There is an issue with this question, though. It does say stretch factor. I could just say it has an a value of 2/3. Otherwise, you could assume that since it is stretched, it should be greater than 1. It should not be a fraction like this. But you could say that perhaps it's 3/2. But we're just going to leave it just like this. It'll be fine. All right, letter B. The parabola with a vertex at 832 that opens up and has a vertical stretch of 1/5. Okay, same thing here. Stretch of 1/5 doesn't sound right, but we're going to put 1/5 as the stretch factor, the a value. I need to switch the sign, so it's negative 8. And keep the other sign the same. Now double check my work. It opens up, yep. Let's move right 8 and up 32. Good, so it matches there. And now we are left with number 2 and number 3. So for number 2, let's find the vertex. This parabola is going to open down, so I want to have negative. It's not stretched or compressed, so I'm going to write down x minus 2 squared plus 4, since it's been moved right 2 and up 4 to 2 comma 4. Again, switch the signs if it's in parentheses, leave it the same if it's not in parentheses. Next up is this problem letter B. The vertex appears to be negative 1 comma 3. It's opening up, so it's going to be x plus 1 squared plus 3, just by switching the sign and not switching it. Now number 3, consider the function y equals 1/2 times x minus 7 squared. Make one change to the function such that the graph opens down. So for it to open down, we need to make it sure it's going to be negative. To move down 2 units, that's going to be our k value. So minus k would be minus 2, down 2 units. To be wider, to be even more wider, it's 1/2 already. So to make it wider, just make it a bigger fraction, like 1/4 or 1/5. And to move it right 3 units, y'all, this has already been moved right 7. So to be right 7 and right 3 more, that would be right 10. So this equation should be y equals 1/2 x minus 10. And that wraps it up for this video.